Hey everybody, this is Mr. Mathlog. This lesson is a fun lesson, so we're starting to get into our statistics unit, module 10. So this one's on populations and samples. So here's our common course strand for our most awesome teachers. So that we're just studying statistics and we're doing samples. And so it's important that we do the correct kind of samples of population. So we'll talk more about that as we get into that. But anything with random is a good sample. Anything with volunteer is typically not a good sample. We'll talk more about that in just a bit, you guys. So our question here is, how can we use a sample to gain information about a population? Okay, so random and not random samples. Okay, when information is being gathered about a group, the entire group of objects, the individuals, it could be the number of bugs in a survey in a field, and it's called the population. It could be the population of people or the population of the kind of coins that you're collecting or whatever the population is. The population is everything that you're considering there. So because gathering information about each member of a large group can sometimes be very difficult or even impossible, researchers often study a part of the population which is called a sample. So the size of the sample and the way the sample is chosen can have an effect of whether the sample is a good representation of the population or not. Okay, so here's some good sampling techniques versus typically not good sampling techniques. So let's say you're doing everybody at the school, and so you have a list of everybody, and you pick every third person, or every fifth person, or every 10th person. That would be a pretty good sampling technique. Okay, so or randomly drawing numbers. So let's say you have the numbers, 1 through at my high school, there's 1,900 people at my high school, so 1 through 1,900, and you randomly draw out of those 1,900, say 20 of them right there, and the word random is a key role. Or you roll dice to pick someone. We'll do that in just a minute, you guys. So typically not good one is pick the first 5 kids that raise their hand. That's not a good representation. That's always the ones that want to volunteer or the ones that always have the answers. So if you're just picking the people that are raising their hands, that's typically not a good sample of the population. Putting out a suggestion box, if you go into a restaurant and they have a suggestion box, well, who usually fills those out? Well, it's people that are usually upset about what they had. So those are the ones that usually fill stuff out. If you had a good experience, you just say thank you and leave. So you typically don't see suggestion boxes unless people with strong opinions. Okay, or getting information from people at a shopping mall. Let's say you want to go see what do people like to buy stuff with, and you go to a shopping mall and you interview people that are coming through the door. Well, that's not good because you're only picking people that like to go shopping. So, there's a lot of people that can't go shopping or just don't like to go shopping. And so what do they like to buy? You're not getting a good representation of the whole population right there. Okay, so typically anything if you see the word random, if it's a random sample, that's a good idea. And anything that's volunteered is not a good idea. Like you hear those I don't know if you listen to the radio, but radios always do call-in polls, and those are terrible ways to sample. Or my district likes to do a poll online all the time, and it's actually a horrible way to do a sample because you're only getting the people that want to do that. Anything that has a volunteer on that is is typically not a good sample of the whole population. Okay, so here's a chart right here, and this chart represents a vegetable garden that has 36 tomato plants arranged in a 6 by 6 row. So this tomato plant has 8, this tomato plant has 45, so here there's 6 rows and then 6 columns. Columns go up and down like a coliseum, those posts that you see at a coliseum. That's how I remember those. So these are columns, and the ones that go sideways are rows. So it's a 6 by 6 array of tomato plants, and these numbers represent how many tomatoes are on the plant. So the gardener wants to know the average number of tomatoes on all of the plants. Okay, so now he or she I think it's a she is not going to go out there and count all the tomatoes on each plant. So what she's going to do is pick the plants and then count the tomatoes on those plants. as a good representation. So each cell tells how many tomatoes are on that particular plant. So the gardener does not know that, you know, this plant has 41 tomatoes on it, but if that gardener picked this plant, you can count the tomatoes on that. Okay, so anyway, so these numbers would not be given, but these are the tomato plants right here. And so the gardener doesn't want to count all the tomatoes in the garden to see how many, what's the average number of tomatoes. So the gardener thinks it would be too time consuming to count all the tomatoes on the plants. So she decides to choose plants at random to find the average number of tomatoes. So she's going to pick a sample of these right here. So to simulate a random selection, we're going to roll two numbered cubes 10 times. And we're going to do that here. So, and then we'll find the cell in the table. So the cell in the table, this would be the first cube. So say we rolled a 3, and then on the second cube we rolled a 4. Then we just find the 3 and the 4, and that plant has 45 tomatoes on it. Okay, and we're going to record the number in each randomly selected cell. So here we go. Okay, so let's see. I have a rolling dice on here somewhere. Where is that? Right there. All right, we're just going to roll these dice. Okay, so here we go. So here's roll 1. Okay, so I see a 5. Whoops, you can't see that right there. So copy and paste that. I don't know if it's going to let me do that. No, it's not. Okay, anyway, so right above here there's a 5, and right above here there's a 3. So I'm going to go down to the row, the first cube. I'm going to go down to row 5, and then over to 3 I see 44. So on the first roll we have the plant that has 44 on here. So let's go ahead and uh, 44. So that's going to go right there. Okay, I'm going to keep doing this. Okay, so patience while I do this. So the second one is going to be, let's roll it again. So I see 3 and a 3. Okay, so that's going to take me right here. A 3 and a 3 is going to get me 14. So I'm going to put that on the second roll is 14. Okay, patience while I go through the 10 different rolls right here. So let's go ahead and roll it again. So roll again. I see row 4. I'm sorry, column 4, row 3. So that's going to take me 4 by 3 is going to take me. Sorry, down 4 over 3, 46. Okay, so I'm going to keep going. 46. Oops, sorry. Whoops, not. Okay, that's my third roll. Let's do another one here, you guys. So the next one's going to be, let's see, 52. So column 5, row 2. So that's going to be column 5, row 2 is this one, 42. So I'm going to put in 42 right there. Sorry for the delay. Usually I have this all pre-programmed, but if you guys have dice in the class, you guys could do this also. So, because everybody's going to have a different number. Okay, so 5 and 2. So 5 and 2, I see 42 again. Did we do 5 and 2 last time? I guess so. No, 4 and 2. Sorry, 4 and 2. Okay, so row 4 and 2 is going to be 45. Okay, let me make sure that's 2. Yeah, 45. All right, so let's keep going. 45, and then we'll do it again. Let's see, 6 and 1. That one's easy to see. That's 18, so I'm going to plug in 18. Come on there, dude. Okay, 18. Okay, let's do the next roll here. So 1 and 1, I can see that's an 8 up there, so I'm going to put 0, 8 just for the spacing right there. And then my 8th roll, I'm going to get 2 and 3. So 2 and 3 looks like row 2, column 3. Row 2, sorry, column 2. Row 3 is 46. Okay, so almost done. And then we're going to average these. So you guys remember how to do average. We add them up and divide by how many rolls we did. In this case, we did 10. All right, 2 more, you guys. Let's keep going. So I see 4 and 2. So here's column 4. Row 2 is 45. So let's keep going. So All right, and then we're going to total all of those up. One more roll. Okay, so 4 and 5. So let's go down to 4 and 5. So column 4, row 5 is 22. Okay, all right, and then we're going to find the average. Remember, the average is, was it 22? Column 4, row 5. No, it wasn't 22, was it? Sorry about this, you guys. So 4 and 5. So column 4, row 5. Yeah, it was 22. Come on. All right. Anyway, so what we're going to do is add these up and then divide by 10. So let's see if I can do this in my head. Okay. So 44 and 14 is going to get me 68. Okay, 60 and 40 is 100, so 114 with the 68 and 46. 114, 156. Let's see. Golly, it's starting to get kind of hard. I'm going to get my calculator out, you guys. Let's just do that. It makes it easier. So, calculator, sorry. I can't add them up very quick in my head, especially when I'm on the spot. So, 44 plus, I'm just starting at the top, 14 plus 46 plus 42 plus 45 and 18 plus 18, 8, 46, 45, and finally 22. Okay, so those add up to 330. So when we take 330 and we divide it by 10, that's going to get us exactly 33. So if I put that in there right there, then the average is going to be 33 tomatoes per plant right there. Okay, so what's the average number of tomatoes on the 10 plants? In our case, so yours would be different if you did it in class, but the ones that we just did right here is 33, okay? So I'm going to go ahead and put that over there. I don't need that anymore. I don't need that anymore. Okay, so let's go ahead and put in 33 right there, and let's answer this next question right here. Okay, so we found out it was 33. Okay, so another way is the gardener decides to choose the plants in the first row. So this is the first row right here. And what's the average of these numbers? Okay, well, there's only 6 of them, so I think I can add these in my head. 8 plus 9 is 17, plus 13 is 30, plus 18 is 48, 58, 68, 72, 82, 87. So if we take 87 and we divide that by 6, let's see if I did that right. So let me clear that out. 87 divided by 6, because there's only 6 in that row, we get 14.5. Okay, so that's what goes in here is 14.5. All right, so if we average the first row only, it's 14.5. Okay, so when we did a random sample of 10 plants using dice, that was a nice random way to do that. We got 33, and then when we just did this first row right here, we got 14.5. That's a substantial difference right there. Okay, so how do the averages we compare with each sampling method? Well, the random sample with the dice gave an average that was more than the average on that first row, because we got 33 and then the first row is only 14.5. Okay, now if you think about it, you guys, how come these plants up here didn't produce as many tomatoes? Then let's look at the rest of them right here. No, this might not have got as much water, or there might be more shade, and these guys are getting more sun. I don't know, or maybe the nutrients in this are doing better, or maybe there's. You guys ever seen a tomato worm? Maybe there's some tomato worms eating those plants up in the back there. Okay, all right. So how do the averages that we got in the sampling method with the dice compare to the average of the entire population? Okay, with each sampling method. So we did 2 sampling methods. The first one was rolling 2 dice 10 times and picking the numbers. That was nice and random. And the second one was picking that first row right there. How do they compare with the average of the entire population? And so somebody added up all those 36 numbers and divided by 36, and we got 28.25. Well, our random sample with the dice, it was closer to the actual average than the first row. The first row was very small. It had a much lower average right there. So So why might the first method give a closer average than the second method, the first method being those dice right there? Well, the plants in the first row seem to have fewer tomatoes than the plants in all the other rows and columns. So it is not a good representation of the whole plot right there. Again, it might be in shade, or it might be not getting enough water or something, or bugs or something. I don't know. Okay, so random samples and bias samples, you guys. A sample in which every person or object or every event has an equal chance of being selected is called a random sample. And anything with the word random is a good sample for your population. And the bigger your sample is, the more accurate it gets. You know, say I was going to average, I don't know, how many pencils you guys have in your desk, and I only picked 2 kids in your class. Well, that wouldn't be a very good sample. I'd have to pick, say there's 30 kids in there. At least I want to pick at least 5 or 6 kids randomly. So as long as I can do it randomly, that would be a good representation. Okay, so a random sample is more likely to represent the entire population than other types of samples. When a sample doesn't accurately or does not accurately represent the population, it is called biased. It's a biased sample. Okay, so here's some examples. So identify the population. So what's the population talking about here, and determine whether each sample is a random sample or is it biased, and explain. Okay, so here's the first one. Roberto wants to know the favorite sports of adults in his hometown. That's the population right there. What's he surveying? His question is adults in his hometown. So he surveys 50 adults at a baseball game. Okay, so is that a nice random sample, or is that biased? Okay, well, the population is the adults at Roberto's hometown, and I'm going to say that this one is biased because people who don't like baseball are probably not going to be at the game of the only the people that he's choosing right there. So it wouldn't be a good representation of the entire population. Okay, so here's the next one. Willis wants to know the favorite type of music for students in his class. He puts the names of all the students in a hat and draws 8 names and surveys those kids. Okay, so that population is all the students in Willis's class right there. And the sample is random because each student has an equal chance of being selected. Okay, so like Roberto, all the adults in his town did not have an equal chance because there were many adults that weren't at the baseball game. Okay, maybe they don't like baseball, so that wouldn't be one of the favorite teams they picked. Okay, or favorite sports. Why do you think samples are used? Why not survey each member of the population? Well, sometimes, you guys, it's often difficult to survey everybody in the population or everything in the population. Say we're going to survey how large, say, beetles were in a field of hay. And well, you couldn't get every beetle, so you'd have to somehow randomly select beetles from all over that hay field or whatever. Okay, so it's often too much time, or sometimes it's just plain old too expensive and too much time consuming right there. So it's impossible to survey everybody or everything, so samples save time and they save money right there. That's why we do samples. Um, so how might we choose a sample of size 20 to determine the preferred practice day of all the players in a soccer league? Okay, so if you play soccer, think of all the players in the soccer league. What would be a good way to sample 20 people? Well, what you could do is place the names of all the players in a hat, or give them all assigned numbers, and then just draw 20 at random right there. That's a good way to do that. That way everybody has an equal chance of being selected. All right, so for a survey, a company manager assigns a number to each of the company's 500 employees and puts the numbers in a bag. The manager chose 20 numbers and surveyed the employees with these numbers. Did the manager choose a random sample? I'm going to say yes, because every employee had an equal chance of being selected right there. Okay, so now once we know how to do a nice random sample, it depends on the types of questions. Is there bias in your questions? Okay, so once we have selected a representative sample of the population, we want to be sure that the data gathering goes without bias. So make sure that the survey questions themselves do not have any sway to help the people make their decisions. Okay. All right. So, for example, sorry, a little tongue twister for me right there. So, in Sacramento County, residents were surveyed about a new skateboard park. Determine whether each survey question may be a biased question or not, and then explain. So, here's question A. Would you like to waste taxpayer money to build a frivolous survey park right there? Okay, can you see that that's definitely biased? It's totally swaying the question right there. So it's biased. It's discouraging residents from saying yes to a park by implying it's a waste of money and it's just frivolous. Okay, here's question B. Do you favor a new skateboard park? Okay, now there's no sway in that right there, so this question is not biased. It does not include anybody's opinion of the question being asked. All right, let's move it up for question C. I'm just going to take it out right there. Okay, so students have shown that a safe place to keep kids out of trouble, have shown that having a safe place to keep kids out of trouble. So would you like to invest taxpayer money to build a skateboard park? Okay, that sounds safe, but it's not, you guys. That's a biased question because it's leading people to say yes because it mentions about having a safe place for kids. So it has to be, so there's no influence on the question right there to make it not biased right there. Okay, so determine whether each question is biased and explain. So when it comes to pets, do you prefer cats? That one's definitely biased because it's mentioning cats. It's suggesting cats. All right, what's your favorite season? Okay, that one is not biased because it's not trying to influence you on which season should be your favorite right there. Okay, so all right, you guys, I hope that lesson makes sense and take care.